So question number 7 involves some inverse work and also some anti-differentiation to work out area. But initially we've been given part of this parabola and it's been graphed for us with a restricted domain. So there it is there. And the first question is the range of f. So the range of f is going to go from -1 all the way up to infinity. So -1 to infinity, a beautiful easy mark. Part B, sketch on the graph the inverse function on the axis and label any endpoints and axial intercepts. Okay, so different colour. -1 and 1 is going to go to -1 and 1. That will be an endpoint. 0 and 0 will stay at 0 and 0. And the looks of it, this is -1 and 3. That will go to 3 and -1. So therefore, we're looking for a square root graph that starts with a gradient that is vertical and goes through there and then continues to go through like that. Use a pencil. Okay, whoops. And let's call that f of -1 of x. Red pencil, red drawing, 0, 0, endpoint labelled. Beautiful. And they're going to give me 2 marks for doing that. Determine the equation of the domain of the inverse function. Okay, so I know that the domain will be the range. So the domain of the inverse of x is equal to -1 to infinity. And I'm going to say that x equals y squared minus 2. Complete the square, I'm going to have y squared minus 2y, half of -2 is -1, plus 1, then minus 1. So it's going to be y minus 1 squared minus 1 is equal to x. Therefore, x plus 1 equals, and then the square root of x plus 1, y minus 1. I want the positive square root because I know my range. No, I want the negative square root because I know this is going to have a maximum of 1 and then go down. So y equals 1 minus the square root of x plus 1. Therefore, f of -1 of x is going to be 1 minus the square root of x plus 1. And there is my domain. And calculate the area of the region enclosed by f, the inverse of f, and the line of y equals e to the minus x. So if I'm looking at my graph, I'm looking at the line that goes through -1 is that line. And the enclosed area that I'm looking for is going to be that area and this area, which will be the same areas. So what would I like to do? I would like to say this area here and then double it. This area here and then double it. So the area I'm looking for is going to be 2 lots of, from 0 to 1, top curve is minus x, minus bottom curve, which is my parabola, and my parabola is x squared minus 2x dx. So that will be the area I'm looking for. So I've got 2 lots of the integral from 0 to 1 of minus x squared plus 2x minus x dx, which will be 2 lots of minus x cubed on 3 minus x squared on 2 from 0 to 1. We've got 2 lots of minus 1/3 minus a half plus 0 plus 0, which is 2 lots of on 6ths to minus 5/6, which is going to be 5/3. Why was it negative? So that worried me a little bit. That should be a positive. because that would give me 2 x's and then minus this x, which makes that positive, which makes that positive, which makes that positive 1/6. So I'm looking for 1/3 square units in total.